So in talking about trig functions in right triangles, let's first take a look at a right triangle, right? So this is a right triangle. It's got three sides. We can immediately label the hypotenuse, right? Which one is the hypotenuse? 5. That's the hypotenuse. And I could, orient this any which way. The hypotenuse is it's not going to change, right? That's the hypotenuse. Now, in trigonometry, angles are usually denoted by the symbol theta, and that looks like this. It's like a 0 with a line in the middle. This is called a theta. It's the Greek letter that makes the th sound. Okay, so it's a theta. Okay, now, so here in my triangle, I have three angles. One of them is the 90-degree angle. That leaves two acute angles. And of those two acute angles, if I just randomly happen to pick one and label it theta, so suppose I label that one theta, then I can redefine my sides a little bit better, right? So one of the legs, so this is one leg, and this is another leg. One of the legs is touching theta, and that we call the adjacent leg. So of these two, which one would that be? The 3. So that's the adjacent. And so this is called what? Opposite. Okay? Now, suppose, so here's a triangle with sides 3, 4, 5. Now suppose I have another triangle. And the sides of that one, if this is theta and that's my right angle, the sides of that one are, let's say this is 6 and this is 12. Okay? Now, suppose, just for fun, what I want it to do is I want it to compare two sides of that blue triangle. I want it to compare the sizes, the lengths of the two sides in that triangle. Okay? So suppose I wanted to compare the lengths of the opposite side and the hypotenuse. So how do their lengths compare? If one is a 6, one is a 12, how do they compare? One is shorter. How much shorter? One is half of the other. That means the hypotenuse is how much of the leg? 2 times, right? So if I wanted to write it in a ratio form, right? If I wanted to compare it like that, like a scale, I would say it's either 2 to 1 or 1 to 2. So I would say the ratio of the opposite side of theta to the hypotenuse is 1 to 2, right? That is a mouthful. Okay, that is really a mouthful. I wish there was a code word, right? So instead of every time I have to say, let's find the ratio of the opposite side of theta to the hypotenuse, I wish that there would be a shorter code word for that. Sine. Okay, so it turns out there is. So sine of theta, all it is just a comparison of two sides of a triangle. And specifically, which two sides? The opposite over the hypotenuse. Okay? Now, if I wanted to compare, okay, so there are 3 sides, right? So how many combinations are there? Well, the opposite and the hypotenuse, the adjacent and the hypotenuse, and then there is the opposite and the adjacent. So So there are 3 different combinations, right? And I have code words for all 3 of those combinations: the sine, the cosine, and the tangent. Now, let's talk about this. So now that we understand that all this is a ratio of the lengths, like the comparison, it's 1 to 2, it's 2 to 3, it's 4 to 5, okay? Let's think about this. Let's just look at sine. Sine compares the opposite to the hypotenuse. Now, in a triangle, which one is always the largest side? The hypotenuse is always the largest side. So if the sine is going to be the opposite side to the hypotenuse, okay, is that which of these two numbers, the opposite of the hypotenuse, is always going to be the bigger one? The bottom one is always going to be the bigger one. So sine of theta, for example, might look like 3 over 5. It might look like 6 over 7. It might look like 1 over 4. Can it look like 4 over 3? No. Can it look like 5 over 2? No. So then what do we know about the value of it? Would it always be, would it be greater than 1, less than 1, or equal to 1? It's always going to be less than 1. Okay? What about the cosine? The cosine compares the adjacent to the hypotenuse. Which of those is always smaller? The adjacent. So the cosine is also always going to look like one of these. So we can clearly say sine and cosine are always less than 1. Now, tangent compares the two legs. Okay? Is there a restriction on which of these legs is going to be larger? No. So tangent can look like 4 over 3. It could look like 3 over 5. All right? So here there is no restriction. All right. Now, if opposite over hypotenuse is sine, we can compare it the other way. Hypotenuse over opposite, that's cosecant. Hypotenuse over adjacent, that's secant. Adjacent over opposite is cotangent. So let's take a look at cosecant and secant. What's in their numerators? The hypotenuse. Is that always the biggest one? Yeah. So what are those fractions going to look like? Always going to be greater than 1. And what about the cotangent? Can't tell, no restrictions. Okay? Now, a little bit about naming them. It's not sin or cos or tan. It's sine, cosine, and tangent. Okay, we have to give the full names of them. And a little bit about writing these. It's never sine equals 4 over 5. It's never like that. What did I miss? It's sine of an angle. So it's always got to be sine of theta is equal to 4 over 5. Sine of A is equal to 4 over 5. Sine of 67 is equal to something. All right? It's never just sine or cosine equals and something else. All right? Never. I will take points out for that. Yes? Not to the negative 1. It's 1 over. Okay? It's 1 over the reciprocal. We're going to get to that. So here, it says find the 6 trig functions for angle G. The first thing I do is highlight angle G. And then I want to label the opposite, the adjacent, and the hypotenuse. So I know that you know that this is the hypotenuse. And opposite is the 24. And adjacent is this one. All right. So now what I want is sine of G, cosine of G, tangent of G. And then I'm also going to get the other one. So sine of G is opposite over hypotenuse, which is what over what? 24 over 40. Never, you always have to reduce it. So we go by 8, 3/5. Cosine of G is 32 over 40, which is 4 over 5. And tangent?
How do you classify 32 as adjacent?
Okay, so I highlighted G, right? Adjacent means touching. Okay. Okay, so now cosecant of G is the reciprocal 5 over 3. Let me get rid of these. Secant of G, 5 over 4. Cotangent of G, 4 over 3. Now, if you wanted to put these in decimals, Go ahead and take out your calculators. For the first one, we're just going to do 3 divided by 5. All right, that's it. You don't touch the sign button if you're given the sides. So what would that be? 3 over 5? Thank you for having your calculators out. How much? I couldn't hear. How much? 0.6. I couldn't hear. So 0.6. If the decimal ends, then it ends. If the decimal is a non-ending decimal, you must go to 4 decimal places. Okay? All right, so 4 over 5 would be 0.8, and 3 over 4? Right. Okay, now 5 over 3 would be? Right, so it's 1.6667. You round. I do not want the repeating bar. Okay? Not 1.6 with a bar. Never. This one is 1.25. 3. It's just 3 repeating. Okay. So much for that. For this one, it says tangent of A is 5 over 3. But we're not given a triangle or anything else. So we're going to draw our own triangle, a right triangle. And I'm going to pick one of the acute angles to label as A. I just randomly picked that one. Now, tangent is what ratio? What over what?
Tangent is L over A.
Opposite over adjacent. So this tells me that I have an angle A. The opposite side is 5. So the opposite side, I'm going to label it 5. The adjacent side is 3. Okay? Right? That gives you 5 over 3 for tangent, right? Now, I need to find the other trig functions. So for example, I need to find sine of A, cosine of A, cosecant of A, secant, and cotangent. All right, now, how would I find this other side? Right, which theorem is that? Okay, what does Pythagorean, what does that word end with? What letter? An N, right? It's Pythagorean, all right? So 5 squared plus 3 squared is equal to c squared. 25 plus 9 is 34, is c squared. So c is just root 34, and we can't simplify that anymore, so we just leave it as root 34. Okay, so now, sine of A is 5 over root 34. You can't have a root in the denominator, so it'll be 5 root 34 over 34. Cosine of A will be 3 over root 34, which is 3 root 34 over 34. Now, cosecant, secant, and cotangent are just the reciprocals, and so it's easier to actually take the reciprocal of that first step. Okay, so the 5 over 34. You already have tangent. So this will be root 34 over 5, root 34 over 3, and 3 over 5.
And why is it root 34 over 5?
It's root 34 over 5 because I take this and I take the reciprocal of it.
Oh, you don't take the reciprocal and simplify it.
It's easier to take the reciprocal of that because if you did the other one, then you would have to re-rationalize, and then it's too much of a mess. You do get the same answer though. So here's what we've been repeating all over. So cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. So those 3 are just the reciprocals of sine, cosine, tangent. All right, so here's another one. This time you have sine of B is equal to 1/4. We're going to label this B and that as the angle, 90-degree angle. So go ahead and label the 1/4, find the missing side, and then find the other trig functions.
Your button for theta.
I'm gonna stop this for 2 minutes and then we're gonna get back to here. So we have cosine tangent, cosecant secant, cotangent. Cosecant is 1 over sine, and since sine is 1 over 4, then cosecant will be 4 over 1. Okay? Okay. All right. So let's talk about special angles. And again, this is straight out of geometry. Remember, you can have your special triangles, and let me go to the bottom here, and then I'll come back. One special triangle is the 30, 60, 90 triangle. And so you have two different acute angles here. You have the 30-degree angle and the 60-degree angle. So they face legs of two different lengths, right? So you have a shorter leg, a longer leg, and then you have the hypotenuse. And the way the sides are compared to one another is if whatever the shorter leg is, the longer leg is that times √3. And whatever the short leg is, the hypotenuse is that times 2. Okay? Now, for the 45, 45, 90, since the acute angles are equal length, you have legs of equal length, and then the hypotenuse is just the leg times √2. If you have any more questions on this, come see me at bonus. But let's go to the algebra part of this, the algebra 2 part of this now. So here I've got those same triangles, okay? Now, suppose I wanted to find the sine of 30 degrees, okay? So I wanted to find the sine of 30 degrees. That would be opposite over hypotenuse, right? Sine of 30 degrees would be opposite x over hypotenuse 2x, which would reduce to what? 1/2. Okay, you know what? So that's fine. Let me just take another random triangle here. Suppose this is 30 degrees, 60, and 90, and this side is 5. How much would this bottom side be? 5 √3 and 10. Okay, now let's find the sine of 30 in this triangle. It'd be opposite over hypotenuse. Opposite over hypotenuse, so 5 over 10, which is 1/2. So no matter what your triangle looks like, if it's a 30, 60, 90 triangle, the sine is always going to be what? 1/2. It's always going to be 1/2, right? So what about the cosine? What would the cosine of 30 be here? Let's find cosine of 30. It would be x √3 over 2x. So the x's go away and it's √3 over 2. No matter what, it's always going to be, it's always going to be √3 over 2. Right? So same thing with tangent. That's what it'll be like. And if you do the ones for the 60s, these are what you get. Okay? I don't want you to memorize this by any means, but you should be able, so I'm going to teach you how to be able to visualize it so that at any given time, you'll just be able to do it. Okay, that's the point of this chapter. Okay, so by the end of this chapter, it'll be like, okay, cosine of 30 degrees, and you should just be able to say √3 over 2. Okay, all right, so let's find the lengths of these triangles here. If there is a 60-degree angle here, then this is 30 degrees. Okay? So this is the short leg, x. And this is the hypotenuse. Right? Now remember how we said the hypotenuse is twice the short leg? So the short leg must be 7. And the other one is 7 √3. Okay? All right. In a 45, 45, 90 triangle, you have two legs of 10, 10, and 10 root 2. So here I'm given the 60-degree angle, which is the long leg. So remember what I said. I said the long leg is equal to the short leg times root 3. So the long leg 10 is equal to the short leg x times root 3. Okay? The long leg is the short leg times root 3. So let's just, okay? So now we're going to divide by root 3 on both sides. So x is 10 over root 3, which is right. Now, the hypotenuse is 2 times the short leg, which is how much? 20 root 3 over 3. Okay? No. Okay. So here we go. Let's find the height of this building. Okay? I've got a right triangle, assuming that, the engineers build this building, correctly. So this is the right triangle. So listen, I'm given an angle, okay? You highlight the angle, and then you want to label the sides that you're working with as opposite, adjacent, or hypotenuse. So is D opposite, adjacent, or hypotenuse? Opposite. And what about 200? Adjacent. And if you have opposite and adjacent, which ratio is that? Tangent. So tangent of what? 76 is equal to what over what? D over 200. Thank you. And now, how do I solve for this? You multiply both sides by 200. And then we're going to put it in our calculator. So, let's see. D is going to be 200 tangent of 76. Okay, before you do anything, press mode. Press mode. Make sure here you are in degree mode, not radian. So go to that third line, go over degree and hit enter. You want to be in degree mode, otherwise you will get the wrong answer. Once you do that, you can now do 200 tangent of 76. Click enter. So this is 802 point something, so it's about 802 feet. So look, it's 802.156. We want to round it to the nearest foot, so we say it's approximately 802 feet. Okay? Cute little bits of notation for you. Okay, now, inverse trig functions. So in this problem, we were given an angle, and we had to find one of the sides. What if it's the angle that you want to find? For that, what I need is an inverse function. Okay? So take a look at this example here. Sine of x equal to 1 over 2. Suppose I told you, okay, look, there is this magical mystery angle. And if I were to take the sine of that mystery angle, I get 1/2. Guess what the angle is? So what you would have to do, take the 1/2 and take the inverse sine of it. That gives you the angle. All right? So the inverse trig functions are used to find the measure of an angle when the sides are given, and we use inverse sine. Sine inverse is how we call it, not sine to the power of -1. Okay, so here we go. Let's find the measures of angle A and B. So let's find angle A first. Here's angle A. Let's pick two sides, randomly two sides. I'm going to pick this one and this one. Can we label those as opposite, adjacent, or hypotenuse? What's the 14? Adjacent and hypotenuse. So what will we use? Cosine. Cosine of what? Equals 14.4 over 17. Now, it's A that I'm looking for. Okay? So A is going to be inverse cosine of 14.4 over 17. All right, so we're going to do second cosine, 14.4 over 17, 32.1. And how would I find B? Right, so A and B together add up to how many degrees? All three of them add up to 180. But if this is 90, then that leaves A and B that add up to 90. So all I need to do is I say B is 90 minus 32.1. And it's right. Okay.
Yeah, you don't have to do it like
right.
straight off the second.
Okay, so I'm going to give you guys about 3 minutes to do example 7, A and B. Go. We can see for part A, we used cosine, and we got 28.1. For part B, we used tangent, and we got 56.3. Okay? Questions? All right. Now, what are angles of elevation and depression? So, take a look at this swimmer right here. Okay? So he's swimming, and his eye level is pretty much sea level, right? Like the lowest it could be. That's his eye level. He looks up, and he sees the lifeguard sitting on his platform or on her platform. So if the horizontal is his eye level, the angle from his eye level up to the lifeguard, we call that the angle of elevation. All right? So same thing, if you're standing, your eye level, right, is at your eyes. And if you see a plane approaching, that angle, that the horizontal, from your eyes and that angle to the pilot, that's the angle of elevation. Now, angle of depression is when you're looking down. So if you're the lifeguard looking down, you're the lifeguard, like here's your eye level, and if you're looking down from that angle is your angle of depression. Okay? All right, so let's take a look at this next problem here. And it says the hill of a roller coaster has an angle of depression of 60 degrees. Now, sometimes you will be given the diagram or picture, sometimes you will not, and you will have to draw it yourself. So how would we draw angle of depression? Well, again, you always have to go eye level. You have to make that horizontal line for eye level. And now if it's angle of depression, we're going down, and that angle there is 60 degrees. Okay? Then you have to make not just a triangle, but a right triangle. Well, in this case, it happens to be that it's 60 degrees. But suppose this was like 68 degrees, then it would not have been 30, 60, 90. Okay? So it says the vertical drop is 195 feet. Again, you find the vertical side, and you call that 195. And it says, what is the length of the hill? So, so trace the hill. This is the hill, right? So that's what you want. You want that. You want X. Okay, hang on. Let's go step by step on this. So what I have, again, what I do is this. Here's my angle, 60 degrees. You have to label the sides as opposite, adjacent, or hypotenuse. So here I have a hypotenuse and I have a opposite. So that's sine, cosine, or tangent? Sine. Okay. So I say sine of 60 is equal to 195 over x. Okay, so now how would I solve this? Because there's a long way and a short way. Okay, so suppose it wasn't sine of 60 though. The sine of 60, by the way, is root 3 over 2, not 1/2. Okay, multiply both sides by x. So we get x sine 60 is equal to 195. And then what? Divide both sides by sine 60. And we're just going to let that hang there for a little bit. Let me show you the other way.
Would you plug it in your calculator?
Here you would plug it in. Now, let me show you the other way. So the other way, which is much faster, but it's identical but faster. Okay? So this sine has a denominator of 1, right? So what you do is this. X equals, and a fraction bar. Figure out which diagonal has no missing information. That's that one. Multiply. So 195 times 1. Which one have I not used? I put that on the bottom, sine of 60. It works like a charm, and you get the same answer much quicker. Okay? Very helpful on SAT type stuff as well. Well, now we're going to plug it in. Notice I didn't use my calculator for any of the intermediate steps. The more rounding you do within the problem, the more and more inaccurate your answer will be. Okay? So 195 over sine of 60. How much is that? And it says to round. It doesn't say. It says estimate. So it's 225.17. And you know what? I'm just going to round approximately to 225 feet. You have to put units, otherwise it makes no sense. Okay? All right, so today's Tuesday. This homework is due tomorrow, Wednesday. Bright and early tomorrow.